Okay, so when we had finished the previous video, we had found out that the equation was this. This is the equation of the line of best fit. It said identify and interpret the correlation coefficient. So when you look on your graphing calculator, it should be showing the R value. So the correlation coefficient is 0.943 if we round. So 0.943. All right, and that is pretty strong. Anything in the nines I'd say is pretty strong, and it is positive. So since it is pretty strong, the residuals, like the residuals mean how far away the points are from the line of best fit, the residuals should be very small, okay? Residuals should be small because it's a strong correlation. So that means the points are closer to the line than they are far away from it. Which means that when you graph the residuals, you should come up with points that are pretty darn close to the x-axis. So it says, is there a causal relationship in the data? Meaning, let's go back and look at what we're talking about here. Meaning, does the amount of advertising dollars cause the yearly attendance to go up or go down? I would say yes. The more you spend on advertising, the more people know about it and attend. So I think it makes sense that it's not just a correlation, that it does cause it. So I would say yes, because more advertising dollars raise awareness and attendance. Like people are more aware of the festival and therefore they attend more. It just kind of makes sense. So it says predict the amount that would be spent on advertising to get 2,000 people to attend the festival. Well, remember, the number of people in attendance is y, so we know that 2,000 goes in for y. So we're going to take our equation, the equation from right here, and we're going to put 2,000 in for y. So it's going to be 2,000 equals 0.19x plus 309. All right, so now to solve, I'm going to subtract the 309 first. And come over here. So 2,000 minus 309 is 1,691. And then I'm going to need to divide by 0.19. All right, and that gets me 8,900. So basically, $8,900 would have to be spent on advertising to get 2,000 people to attend this festival. Okay, domain and range. Remember, domain is how far it goes to the left. So it does go to the left forever, and it goes to the right forever. And there really isn't a hole. I know there's an open circle right here, but there's not a hole in the graph because at the same point, there's also a closed circle. So it does exist at this point. Even though it doesn't exist here, it does exist right here. So that means that it goes forever to the left and the right. So the domain is either negative infinity to positive infinity or all real numbers. All right, the range is also the same because it does go up and down forever. So it's negative infinity to positive infinity or all real numbers. Okay, so on this question, this is a piecewise function. There are 3 pieces, and how you know which of the pieces to use is by looking at the domain over here. So this is the domain. So on A, it says g of -4. This is an input, so this means x is -4. So if you look at the domain, that would be this one because -4 is less than or equal to -1. So it fits with this top domain, so that means you're going to use this top equation. So we're going to use, we're going to use this equation, and we're going to plug in -4 for the x value. So we're going to have negative, and the x is -4 plus 4. So I'm using -x plus 4. So -4 becomes +4, and 4 plus 4 is 8. All right, on B, the x value is -1, so you look at the domain. It would be this top equation again because -1 is less than or equal to -1. So it's this top equation again, so we're using -x plus 4 as our equation. So we plug in -1 for x. -1 is 1. 1 plus 4 is 5. All right, on C, this equation, x is 0, And so that goes with this middle domain because 0 is bigger than -1, but smaller than 2. It goes right in here. 0 is between -1 and 2. So that means use this equation. This equation is 3, so it means no matter what the x value is, you get out an answer of 3. Okay, this number is 1, so that fits in also to this domain because 1 is between -1 and 2. So that means it's this equation, and since there's no x, it just means your y value, your output, is 3. All right, let's look at this. On this one, the x value is 2, so it doesn't fit into this equation because this states that the x is smaller than or less than 2. So it goes with this equation, the bottom one, because 2 is greater than or equal to 2. So it fits with the bottom one, so it tells me to use this equation, 2x minus 5. So we plug in 2 for x because 2 is the input. We get 4 minus 5, which is -1. And then on f, the x value is 5. That goes with this bottom equation because 5 is greater than or equal to 2. So that tells me, oh yeah, that works. So that tells me go with the bottom equation, 2x minus 5. Which remember, the x value is 5, so plug in 5 for the input. And that gets you 10 minus 5, which is 5. Okay, so on this one, you're talking about if a correlation is likely. So if there's a correlation and if it could cause it. Okay, so sometimes correlation means is there a connection between the two, but causal means it actually causes the other to change. So on A, the amount of time spent talking on a cell phone and the remaining battery life. So the more time you spend talking on a cell phone will change your battery life. So I would say yes to correlation. There's definitely a correlation between them, and yes to a causation or causal, meaning it causes it, because the more time you talk on a cell phone, the more battery is used up. So it's not just an accident or a connection that doesn't have a reason. It's the actual physical act of talking on it is decreasing the battery usage, okay, or the battery availability. So the length of your hair in your grade in Algebra 1, there should be no correlation. It's not like people with longer hair get better grades in Algebra 1. If your data showed that, then it would just be like a random thing that just happened. It would not be, it would not actually like have any relation to your grade in your hair. Okay, and on this one, the weight of a horse and the length of its neck. This one I can kind of vary on. As a horse gets larger, its neck does get longer. So as it's weighing more, its neck, it should also be just getting larger in general, including its neck. But on the flip side, it could just be, kind of a stout or a heavier horse versus like a leaner horse. And so that could vary. So I kind of put not necessarily. Correlated, not necessarily correlated. And it could just because it could be a heavy horse. It could just be kind of a chunkier horse. So it could have more weight, could lead to just a regular neck. That one's kind of hard. So on a test, we'll have it be really cut and dry and obvious. Okay, on this question, it says, here's the equation. It represents the cost in dollars of making X number of gourmet cupcakes. So X is how many cupcakes you make. Y is how much it costs in dollars. So the slope is 3/2. So when it says interpret the slope in the context of the situation, there are 3 ways to do it. If you leave it as 3/2, the top number is Y, which was cost in dollars. The bottom number is X, which was cupcakes. So basically that means it costs $3 for every 2 cupcakes. That's the cost to make 2 cupcakes. Now another way you could do that is you could do 3/2 is 1.5. So think of that as 1.5 over 1. And so that tells me that the cost is $1.50 to make every 1 cupcake. So when they say interpret the slope in the context, they just mean tell what it means in this specific problem. What do the numbers represent? So now it says write the equation as a linear function in slope-intercept form. So all you have to do is distribute the 3 halves. So that's going to get us, sorry I didn't leave you much room here, 3 halves x. 3 times negative 8 is negative 24, divided by 2 is negative 12, and then add 12. All right, so I get y equals 3 halves x. So that's slope-intercept form. Then negative 12 plus 12 makes 0, and that's why there's not a y-intercept. Or I guess the y-intercept is 0. So the linear function, use it to determine the cost of making 20 cupcakes. Well, remember, x is how many cupcakes. So if you're saying 20 cupcakes, that means you know x. So you would plug in 20 for x. And so then we can type in a calculator, and we get that it would cost $30 to make 20 cupcakes.